Okay, so let me see where we left. Okay, so we are in the trees part and we are left with three easy problems and one hard problem. Okay, so today we will finish trees section. Let's start with the first easy question, balanced binary tree. Okay, mm, so first we will read out the problem. So the problem says given a binary tree, determine if it height balanced. Okay, so what does a height balanced tree mean? Okay, so height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one. Okay, so this is the definition of height balanced binary tree. So okay, so a height of a balanced binary tree in a height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than one. Okay, so for this node the depth of the left subtree is 1 and the depth of the right subtree is 2, so 2 minus 1 is 1. Okay, so for this subtree the left for this node the left part has a height of 1, right part has a height of 1, difference is 0. So this is a height balanced tree. So for height balanced tree, so the condition will be something like height of left minus height of right, its modulus should be smaller than equal to 1. So this is the definition of a height balanced tree. So for example here for 1 the right subtree has a height of 1, but our depth of the left part is 1 2 3 3, so 3 minus 1 is 2, so basically it's greater than 1, so it is not a height balanced tree. Okay, so we have a base condition where our root is null, then in that case our tree is height balanced. Okay, so otherwise let's say we will call a function util, we will pass our root. Okay, so util should be a boolean type. Okay, so for a particular node we will calculate the maximum height of its left part and maximum height of its right part. Okay, mm, let's say we call it a int function because we will be returning heights. So if our root is null, then in that case the height will be 0. Okay, so now we will calculate height of the left part. So left part's height will be, we will move to the left part, root dot wait a second, root dot left. For right part's height, we will move to the right part. Okay. So suppose we have find out the left part's height and right part's height. What we need to check is, we need to check if our mat dot absolute value. So absolute value is nothing, just a mode of right part minus left part. If it's greater than 1, then in that case our tree is not balanced. Okay. If this condition doesn't met, then for this root we need to return its max height to this root. So for that, what I need to do is, I need to add 1 into max of left part or right part. So how that will work? I need to return 1 plus max of left part and right part. So our tree is not balanced here. So what we will gonna do? We will initialize a boolean balanced. We will initialize this with true. That we will assume our what we say, a tree is root is balanced. In this case, what we will do is, we will make our balanced as false. And at the end we can return our balanced boolean. So let's dry run for this example. So we have passed 3 into our this function, then we go to the left part 9, then for 9 also we go to the left part. So left part of the 9 is null, so it will return 0. So left part of the 9 and right part of the 9 will return 0, and this will not follow. So for the call of 9 we will return 1, that we have 1 depth on the left of the 3. And for right part, then we go to the right part, and for that we go to the left part. Similarly, we will return 1 from this side, 1 from this side to 20, and for 20's case we will return 2 to the 3. So yeah, that's how we will get a balanced tree. Okay, let's submit this. Okay, we have submission. Let's look at the previous submission, if it was something different than this. Okay, so what I am doing is, okay, I'm just using same approach. Wherever I am getting a -1, I am returning -1. So here I don't need a global variable. means instead of setting the false, I am returning a -1 and checking if my left call or right call subtree are not balanced. Then in that case I am returning -1 and checking whether my this is equal to or not -1. If it's -1, then I am returning false. So pretty same approach. So let's move to the same tree problem. Okay, so the problem, let's read out the problem first. So the problem says, given the roots of two binary trees p and q, write a function to check if they are same or not. Okay, two binary trees are considered same if they are structurally identical and nodes have the same values. Okay, same trees. Okay, okay. So same tree basically means same tree, means trees need to be same. So this root is equals to this root. This root's left part is 2. This root's left part is also 2. This root's right part is 3. This root's right part is also 3. For this case, this root's left part is 2, but this root's left part is null, so they are not identical. For this case, this root's left part is 2. For this case, left part is 1, so they are not identical as their left part is different, so we are therefore returning false. So I think this is a pretty basic question. So we suppose we check if my p node is null and my q node is also null, that means these are same nodes. This means these are same nodes, so I will return true here. Otherwise, suppose if my p node is null and my q node is not null, this means my nodes are not equal, or opposite of this condition, that my p node is not null but my q node is null. Then this situation means my nodes are not identical, so I will return false. Now I have checked all the possible null values, so we will now can compare the values of the nodes which are not null. So after these checks, we will have both p and q will have some value. So what we can do, we can check that if p dot value, if p dot value is not equal to q dot value, that in that case we can return false. Okay, now we have checked the possibility of the current nodes. So now we need to move to the left part and the right part of the both nodes. So we will move to the left part of the p node as well as left part of the q node, and also we will move okay, so these need to be identical, so we will move to the right part and we will move to the left part. So I think we are comparing every node basically and their values. Okay, so we have got some error in the first case itself. So what's that? Okay, wait a second. Okay, so we need to have q dot write. Let's submit solution. Okay, we have got a submission. I think my previous submission was also same. So it was in February 24. uh, where I can, okay, so it's okay, so I have submitted it in Go language, I think. Yeah, it's Go. So it's the same code. So in Go we use different notation. I think this is Pascal's notation, but in Java we use camel case. So in camel case, the function name is starting from the smaller letter and then capital letter of every word. But here it starts with the capital itself in Go language. So we can move to this question now. Subtree of another tree. Okay, so question says, given the root of two binary trees, root and subroot. Okay, so we are given two trees. Return true if there is a subtree of root with the same structure nodes. Okay, false otherwise. Okay, a subtree of a binary tree is a tree that consists of nodes in the tree and all its nodes descendants. The tree could be considered as a subtree of itself. Okay. Okay, so I think it's not that complicated. If means we need this, we need to find or we need to check whether this subroot exists in this root or not. For this particular example, this subroot is existing in this root. But for this example, let's say if you argue that this subtree is existing here, but it's not the case because here the left node of the 2 is 0, but here left node of the 2 is null. So that's why we are returning false, that it is not a valid subroot of the root. So we need to check whether this exists in the root or not. So suppose for every node we can use the previous code, I think, which we used in same tree. Let's copy that code. So basically this is a same tree function. So how I can use this function is, let me paste it here. So I will transverse every node of the root, and for every node of the root I can call this same tree function. Let's first transverse root, also pass the subroot. In order tree node root, tree node subroot. If my root becomes null, then I will return. Basically I am transversing the every node of the root. So now I move to the left part. Let me call it pre-order. Okay, so the left part, pre-order to the right part. So for every node I will call is same tree function. I will compare this root with this subroot. Okay, so if my same tree function returns true, in that case I can say let's say a boolean subroot found as false, and if I found the subroot, then I can say I have found the subroot. Okay, and I can return the subroot at the end. So this is basically a n square approach. Let me hit the run button. Okay, we have got some error. Okay, so we need one argument also here, that is a subroot. Okay, so we are getting correct output. So I think this is a I don't think, no, it's not about thinking, but it is a n square approach. So we need to think of a approach where we can solve it in big of n. Without using a global variable, we can use it like we have used in previous approach. In the case we found a same root, we can return one that we have found, and we can have a left part, we can have right part. So if left equals to 1, we can return 1. If right equals to 1, we can return 1. I think this should work. This should also work. Okay, so now we have removed dependency on the global variable. Okay, so I think we should think of a big of n approach, that how we can solve it in a big of n approach. A subtree of a binary tree is a tree that consists of a node in a tree and all these node descendants. Hmm, how can we do it in big of an approach? We need to find this element, this should be equal, then this should be equal, this should be equal. One thing we can say is that these nodes of this subroot will be leaf nodes itself, but how can we reach a leaf node? Okay, it's the same approach, but I have made it complicated, don't know why. Use some list. Hmm, let's first submit our this approach if it's working or not. I think it should work. Okay, it's working, but isn't there any way to solve it in big of an approach? Java tree transversal. Okay, so what people are doing here is they are serializing the tree and then using pattern matching algorithms. Okay, so I think our this approach will get covered in the last question, which is serializing and deserializing a tree. So let's jump to that approach first. Okay, so let me mark this as done. Okay, so now we are left with this question: serialize and deserialize a binary tree. Okay, so I have attempted this solution before and haven't submitted any solution. I tried but not able to solve it. Today we will try to solve this question. Okay, so the question says serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection link to be constructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction how you serialize deserialize algorithm should work. You just need to ensure that the binary tree can be serialized to a string and the string can be deserialized to the original tree structure. Clarification: the input output format is same as how lead code serializes a binary tree. How lead code serialize. Okay, so This is one node. Serialized format is not but a way to represent a binary tree in printable format using level order transversal. Okay, for this one level, then 2 and 3 level. For this one level, then left of one is null, then null, then 2, then 3, then null, also assume a null here, 5, then 4 and 7, then 3 null, 2 null, -1, null, 9. Okay, the number of nodes in the tree is in the range. Okay, so the question is saying that we need to convert this tree into a string. Then that string means we are serializing this tree. Then this string will be given as a input to our deserialized function, and we need to give back this tree itself. So we need to implement this class, codec class. Okay, so values in our values can be negative and positive also. Okay, so I think we can use this approach that we can serialize the tree into serialized tree using level order transversal, and then we can deserialize our tree. For example, this tree we can see if we do its level order transversal. So this is node 1, so we can write node 1, then star, then we can write node 2, star, then we can write node 3, okay, star, then we move to 2 node, and its left part will be null, star, then its right part of 2 is also null. Okay, okay, then left part of 3 is 4, star, then right part of the 3 is 5. Okay, after we reach this condition, our queue will become empty in level order transversal. So this is the serialized version of the tree. Okay, this is the serialized version. Now we need to deserialize this tree. So basically we will be returning this string. For this case, and now our data will be this string, and we need to return this root. Okay, so how we will gonna return the root? Data. Okay, so we will split our string into a character array. So split by stars, so we will split our string at every star. So how, after splitting, what we are left with, we will be left with these characters 3, sorry, strings. These will be strings. This will be a string array. Null, null, then 4, then 5. Okay, now we need to construct the tree from this array. Okay, so construct this node, we will start from this 0th index. Okay, so our 0th index will be root. Okay, so what will be our left value? 1 index will be our left value and 2 index will be our right value. Okay, so I think there is a formula that is the index of the left part will be 2i plus 1, 2i, and right part will be 2i, 2 into I plus 1. Let's see, for the case of 0, this is not working. Let's say this is our formula. Now for this case, index is 1, so its left part is this 4th index. So for 1, its left part is 0, 1, 2, 3, 3 index. So 2 into 1, 2 plus 1, 3. Okay, so left index is 3. So basically this is the left index formula and this is the right index formula. For 3, the left index will be 0, 1, 2. 2 into 2, 4 plus 5. So 0, 1, 2, 3, 4, 5. So this is 5. Because the nodes in the levels are something like that, we have one node in the first level, then our node increases by 2. Okay, then our node increases by 4. So basically this is the first level, this is the second level, and this is the third level. Okay, so I think we can now implement this approach, or do we have any issue here? We can handle negative values. We can check if value is null. Okay. I don't think we will encounter any issue while implementing this approach. So let's start implementing. So first we need to form this string by level order transversal. So for our level order transversal we need a queue of tree node. Okay, so we have initialized a queue. So our queue, the first value in the queue will be our root value, and we will iterate our queue until it's not empty. Okay, so we will find size of our queue. So this is the size of the current level size. So we will now pop this much elements from our queue, because this much elements are present in current level. So my current tree node will be queue dot poll. Okay, also I need a string builder. Basically string builder are nothing but mutable strings in Java. So this is basically a string. So we will be converting this string builder to string at the end and returning it in the serialized form. So yeah, so this is our current node. So we will check if our current node is null, then what we'll gonna do is we will gonna append a null to our string builder. Otherwise we will append the value of the current node. Okay, null plus star, a current dot value, and at the end we will add a star. Okay, and if our current node is not null, and if our current node is not null and current dot left is also okay, so in the case of null we need to add null. Current node is not null, then what we will do, okay, in the case of all nulls we have to avoid adding null. Okay, then in that case, what I will do, I will add to my queue current dot left and add current dot right. Okay, actually what we are missing here is we are also adding null values which are at the end of 4 and 5. How we can avoid adding null values at the end? Let me print a string to just visualize what we are storing now. Okay, I think this should work. Means for now this should print something. Let's comment this out and return null. Okay, we have got some issue. Okay, println. Okay, so that what I was trying to say, that we are getting these nulls also at the end, but we are not supposed to get not supposed to add this level. It does don't cause any issue, but it will just increase our strings length. That's how it will cause a issue. Otherwise it is also fine. Okay, so let's go with this itself. So now we have serialized our tree into this form. Okay, which tree? So left part will be we have serialized this tree into this form. Okay, so we will now deserialize this tree. So what we will do, we will call a function, let's say a util function. We provide it our data. So before providing data, uh, let's split our data. Let's split this string wherever we get a star. Let's print and see. Dot print s and a gap. Let's run. Sorry, it was a string. Okay, Don't know why we are getting this error. Dangling meta character star near zero index. Suppose we return something like this string and see if this still fails. Okay, this is still failing, so I think we need to check how our split function works. Let's ask from GPT. Okay, if you want to split a string using star as a delimiter, you must escape the star because it is a special character in a regular expression. It represents 0 or more of preceding character or group. What else we can use as delimiter? Okay, we can use a comma. We can, for dot we also need. Okay, so instead of star, let's just put comma here and split it at comma. Okay, so now we are getting this split 1 2 3. Okay, so let's see if size of the array is also correct or not. So size of our array is 11. 1 2 3 4 5 6 7 8 9 10 11. Okay, so now we have a serialized string array. So now we need to deserialize it into a tree. So let's call a util function and pass this array, and suppose we are at a 0th index. Okay, at the end we should return this function also, means this function should return our tree node. Okay, so public tree node util, let's say call these nodes string nodes and its index. Okay, so if index becomes greater than or equal to node length, in that case we will return null. Now we will construct our current node. If our nodes dot idx, if it's not equal to null, in that case we we will construct our node, and our node's value will be, we will parse this value, this string value into integer. Okay, so now new tree node, and we'll pass this value, means the value will be so this is our node. Else we will return null from here itself. Now we need to construct roots left part, which will be we call our util function and pass these nodes. Now our index will be 2 into idx plus 1 will be left part, and 2 into idx plus 2 will be right part, and at the end we will return our root. Okay, I think we can try running it. Okay, we have got some error. Equals, I think we need to use. Okay, let's try submitting this. Okay, we have got a wrong answer. For this part our output is not correct. Let's see what tree we have. Okay, we have this tree. And we are giving till 5 only. Let's see how we have serialized this tree. Okay, I think our serialization is correct, but our deserialization is not correct. The ones left part is this, right part is this, then we move to this index. This index and this index. Okay, after this index, Okay, this is null, this is null. Then I reach to 3. 3's left part is 4. 3's right part is 5. 4's left parts is supposed to be 6. So what is 4's position? 0, 1, 2, 3, 4, 5. So okay, so we are missing the null values here at this level. So that is why we are not able to figure out. Okay. Okay, what we can do is we can add null values in the case of nulls here also. Else suppose we add q dot add null and q dot add null to maintain our count. Okay, but we need to make sure a very boolean that when our all values are null, boolean all null is equals to true. We will set our all null value variable to false, and at the end we can check if all values are null, then in that case we can break. Then our serialization will become correct, I think. Okay, so our memory limit is getting exceeded. Okay, let's see. All null. If current is null, okay, current dot left, current dot right. If current is null, Let's see what size we are getting every time. Okay. Okay, we need to put a break here instead of that position. Okay, so now our serialization is correct, but it's too lengthy. I think let's see if submitting this if this works. Okay, so our memory limit is exceeded. So instead of null, can we just put something like hash? And in the case of hash, means hash has a 3 times less length than null. So I think that should work. Why we are getting TLE? I think we need to remove that all the nodes which are at the end, all the hash which are at the end. So I think before breaking we need to remove size hash from end. Let's see a function substring of string builder. Subsequence 4 5 6 7. Okay, so what we need to do here is from 0 to sp.length minus size plus 1. I think string cannot be converted to string builder. So is it a string? Okay, so it return a string. So let's serialized, and at the end we will return the serialized string. Okay, let's just remove this for a second and check if this is working or not. Okay, so this is working for these cases. Let me print. Okay, we are still getting these unnecessary strings at the end. Okay, so we have these two character instead of one. So we need 2 into size. Okay, now also we have more characters. Okay, we are still getting this string at the end. This for here, and these three for here. Let's print. Let's run for this part. I think we need to change our approach of doing this question. This was my previous summation also same. Previously also I was using the same approach.